I'm super excited to be here. Last year was my first talk ever except at a conference, so definitely excited to be back here. Had a great experience last year. Scobie said I'm Terence. I'm the dude who wears the blue hat, walks around, kind of part of my MO. I'm the Ruby steward at Heroku, which means I handle your experience when you push apps up there. So if anything's broken, then it's definitely my fault, and if you hate it, then it's really my fault. So if you have any of those problems, come talk to me. Here's my contact info. I'm Hone02 on Twitter, just Hone on GitHub, and then Terence@Heroku.com. That's with one R, no A's. People like to misspell my name a lot, because if you do, I won't get the email. Come from Austin, Texas, not the Bay Area, though I haven't been home in 3.5 months, so I guess my stuff lives there. If you're ever in town, I would love to take you out for tacos, so just feel free to reach out to me and we can grab some tacos, my treat. So one of the awesome things about Austin is that we have great barbecue, so there's this awesome, I guess, like local barbecue chain that's like now all over Texas that started in Austin called Rudy's. And they have these amazing hand washing machines. You like stick your hands in them, and like after 30 seconds, your hands are clean after like eating a bunch of greasy barbecue food. And the best part is you get these like stickers at the end. So when I go home this Saturday, I'm gonna go and collect all these stickers and hand them out on my talking tour. I think it'd be a great collection. So if you guys know Constantine, it's like my favorite sticker that he has on his laptop. It's the I have 10 sticker. So in the community, I work on Bundler, the Bundler API, which I'm going to talk about today, Retu with help from Steve, and then done a bunch of stuff with Rails girls around the world. So if you haven't done anything with Rails Grid or Rails girls or any type of teaching organization where you're talking to beginners, I would highly recommend it. It's a great experience to sort of just like see the world from their view and realize how much stuff you forget that you know and how hard it actually is to be a beginner. So I like to do this every so often just to realize like how much it still sucks to start programming. And so I was just in Australia last month, and Corey Haynes gave the opening keynote. And so Corey's known for both being Corey Haynes and his title being Corey Haynes. And one of the things he talked about was this emulation march where he would take on the title of someone else that he wanted to aspire to. So he took on the title of Aaron Patterson because he was so appreciative of all the work Aaron did in open source, so twice a week he's going to do open source work. And I, as well, am inspired by Aaron Patterson, but for different reasons. So Aaron also does this Friday hug thing. So basically he would like take a picture of himself, hugging the camera, and then tweet it every Friday. So this is a picture of him and his awesome cat, Gorbachev Puff Puff Underhorse, who also has a Twitter account, Gorby Puff. If you're not following it, I would highly recommend that. So since Aaron started talking to me about this and I started seeing it, or one of the things that Aaron does, he was just in SF last week for Waza, and you're just like walking down the street and some guy comes up to him and is like, hey, Friday hug, and then just keeps walking. And so I thought that was pretty awesome. So I was pretty inspired by that. So I've kind of gone around the world while talking after coming to Ruby on Rails. So I went to Finland, we did one in Singapore, this is in Amsterdam, Lyon, Seattle, and then there's like a bunch of other ones. And so the Friday Hug Twitter account sort of dubbed me a Friday Hug evangelist. So today is Friday, and I'm at a Ruby conference, so it only makes sense to give a Friday hug. So if y'all could stand up and assume a Friday hug standing picture. Thanks, guys. It's all my favorite part of public speaking. So on to the talk. So today I'm going to talk about sort of a little bit about what I did talk about last year. So the bundler and the client just in the beginning to sort of people who weren't here last year, and to give you a sense of like why we actually have the API, talk about the old rubygems.org instruction, sort of the incident of when it went down. And then next, talk about the Bundler API that us on the Bundler team built and maintained. And depending on how much time we have and how much people want to eat lunch, I have a bonus round. So I guess I'll take a poll at the end and see if we want to go and talk about extra things. So as I guess someone asked in the last presentation, who's Jessica? So this is Jessica Lynn Suttles. She is JL Suttles on Twitter, and if you aren't following her, you should. I guess today is like Jessica Day. And the reason I have a picture of her in here is yesterday she's joining the Bundler Corps, so if we could all congratulate her for joining the Bundler team. Super excited to have her. I think in the 2 years that I've been working on it, we haven't had anyone else join the team, so this is like the first person that's going to be helping us with stuff. So super excited of having another person on the team helping Andre and I and Yehuda. So congratulations. So on to Bundler. So what is Bundler for people who aren't familiar? Just at a high level, it's a gem dependency manager for your Ruby application. So if you guys were here for the older days of Rails 2.3, I'm sure you remember like the config gem stuff. I remember starting an application for my first like Ruby job back in the day at Other Inbox in Austin. And it would take literally like a whole day just to get your app up and running because you had to figure out what gems to install. Even they were listed in the config.gem, there's gems that weren't in there that you had to install, and then you have to like talk to your coworkers to figure out the exact gems you had to install. I remember we were using like Cucumber back in the day, so the versions of Cucumber weren't even really backwards compatible. So like if you're off by a patch release, like it would break your whole integration test suite. And so when I saw Yehuda and Carl give a presentation on Bundler, I thought it was like the best thing since sliced bread. So the interface that most of you are familiar with is just bundle install or bundle, which defaults to the install command. And literally you just have this gem file that has, you list your sources, and usually this is just rubygems and any other private repos you have, and then you just list the gems by gem name and then sort of the requirements that you have there. So this is the sample gem file we'll be using in this presentation. So when I was doing this presentation last year, I think the latest version back then was Bundler 1022. And then we ran this bundle install command over a year ago, and we would get this fetching source index message. And if you're familiar with that, you'd end up waiting a really long time. And so for that simple gem file that was just Sinatra, it took about 18 seconds, which for a lot of people, we got a bunch of those XKCD compiling jokes related to Bundler, because they would go get a coffee or make a sandwich when they type bundle install every time. And in order to really understand like why this is really that slow, we have to look into sort of how Bundler does all the resolve stuff. So Bundler has this class called index, and it does a bunch of stuff, but most importantly, it contains all these specification information needed to actually do the resolve. And it has this instance variable called specs, which by key, it's the name of the gem, so the spec name, and then the value is this array of specs that it has. And we need to go and fetch all the specs to fill up the index. So inside this index class, we have remote specs, which goes through all the remotes that you're listing in your gem files, all the sources, and calls this fetch all remote specs on them. And inside there, we call spec fetcher from rubygems, and you notice we call it twice. And for each of these, we get back essentially the monitor index. And so what the monitor index is, it's a list of all the gems that have ever been released to that gem server. And the reason we have to call it twice is because in the older versions of rubygems, I believe this is fixed in rubygems too, but when you would call true, it actually wouldn't return both the actual specs and then the pre-release specs, so we had to fetch them twice and then combine them. And I believe Eric fixed this in rubygems too, so thanks. So a lot of people back in the day used to think, oh, the specs is like really large, this is why it takes a really long time to actually sort of do this resolve, why it takes like 18 seconds. But I went and did this, I guess, about a month ago, and the main index was only about 1.2 megabytes. So unless you're on like a really, really slow connection, like I don't imagine this taking a very long time. And if we go and look at what's inside this index itself, we see that it's a gzip file of this array of this 3 tuple, which is the gem name, the gem version, the platform here. And then inside of Bundler, we have this remote specification class, which is kind of just a fake gem specification that quacks like a gem specification. And inside, we keep track of the name, the version, the platform. And then we have this fourth option here, the spec fetcher, which allows us to fetch any other extra information we need. So when we call a gem remote fetcher, on this fetcher, we can download the actual gem spec and get any other information that's necessary. So one of the things that you notice is that there's no dependency information here. So without that, you can't actually do the resolve because you have no idea. So when we fetch Sinatra, you actually have, Bundler has no idea what the dependencies are that actually needs to do the resolve. So we would actually need to go and fetch this gem spec for each of these things that during the resolver to get the dependency that it needs. This is kind of why it has to construct the whole graph here. It's because you don't have any of the dependency information from the index. So if we go back to that remote specs method that the index calls, we see that we fetch all the specs and then we go through and sort of create all these remote specification objects for every single gem version platform tuple that ever exists on rubygems. And as you can imagine, this takes up a lot of memory. So back in the day when Bundler 1.0 first came out, if you had like a Lino 256 megabyte EPS, you couldn't run bundle install because it just would consume too much memory and not be able to finish. So we realized this was a problem on the Bundler team, and this was one of the first things that I worked on after joining post 1.0. So using Bundler 1.2.3, we see that we get this fetching gem metadata thing instead of the fetching source index. And when that happens, that gem file finishes in about 3 seconds, which is a little bit faster than the 18 seconds from before. And the secret to this is that rubygems at the time, when we were first building this, built this endpoint that we could hit. This rubygems.org API v1 dependencies. And it takes sort of this gems parameter of any comma separated value list of all the any of the gems that you want. And so in our case, we just pass sort of the top level of dependencies of things that you list in the gem file here. And so if we go and look at what that returns, we see that it's pretty similar to the index, but now we also get the dependency information. So we get the name, the version number of the gem, the platform, and all of its dependencies, and we get an array of that. So if you pass in Sinatra, it gives you every single version of that, and then you get its set of dependencies there. So now we can actually use a recursive method. So this is the recursive method inside of Bundler that sort of goes through and continually hits the endpoint to sort of construct a much smaller graph. So if we just have Sinatra in there, we don't actually care about Rails and its dependencies or any other gem that doesn't really sort of fit in that graph there. And then, so instead of building a bunch of remote specifications, we can build this endpoint specification that instead of taking the spec fetcher, it takes the dependency information. So now we know that we have the dependencies and we don't have to fetch them. This allows us to construct a significantly smaller graph. So if we sort of walk through what that looks like with just that Sinatra example, we first pass in Sinatra, and then it returns tilt, rack protection, rack, mongrel. So these are any dependencies that ever existed as a first level dependency of Sinatra. And we go and query all those gems and get their dependencies, and we construct that list. And eventually we get down to rack, and then once we get an empty list, we know we're done, and we have the complete graph that we're ever going to query on. And so given that, we can hand that to the resolver, and it will finish and sort of do your resolve there. So that's sort of all the client-side stuff leading up to like why we're using the endpoints and what it really looks like on the client side. So on to new stuff for this year. So we move over to the server side on rubygems.org. The old setup from last year was we had this single box. It was this quad-core machine. I don't remember how much RAM it was running, but it contained every single piece of the rubygems infrastructure that it needs to run. So it includes the Rails app that is on rubygems/rubygems.org on GitHub. It contained the Postgres server that was using to store user account information and gem metadata stuff, as well as the Redis stuff for caching download counts and whatnot, as well as, I believe, the Nginx box that was sitting, the Nginx server that was sitting in the front to sort of proxy requests and handle static assets. But on Wednesday, October 17th, the rubygems.org went down, and one of the things that they had to do to bring it back up was that they took down the bundler API. And we realized in the postmortem when we were talking about it was that bundler API accounted for 70 to 80% of the traffic to that box. And it also took up 308% of the 400% of CPU available most of the time. And this was due to Marshall because bundler doesn't have any dependencies, and if they do, they're rendered in. And so one of the things that when Nick built this was that he returned the thing as a Marshall dump and then sent it to bundler, and then bundler would unmarshal it and then feed it in. And so having to marshal the data for every single request is CPU intensive. So they disabled the bundler API and brought rubygems.org back up. But I know from both working at Roku and talking with Andre, like this wasn't really a great solution for us because this meant we all went back to the bundler 1.0 days. Like you had to fetch the indexes every time, and there was no API, and sort of the whole Ruby community was feeling that pain. And so I've been really lucky at Roku that when this happened, they allowed me to just sort of drop everything I was working on and sort of prototype something to get something up and running. So we started working on this new bundler API, and the architecture for it was that we had this simple Sinatra app because we just had to sort of mock up that one API endpoint that you pass the gems to and have it return results back. And then we wanted to move that load off of the current rubygems.org infrastructure so that it could come back up and not really be affected, and then Nginx could just route the connection to some other service where it wasn't just storing the server there. The other things we needed to do was, since this is now a separate piece of the infrastructure, we had to somehow keep all of our data up to date, because at the end of the day, we have to return the metadata that people are looking for. And at the time, we wanted to do webhook stuff. So rubygems, if you don't know, has this webhooks infrastructure that allows you to get notified for specific gems or all gems when new gems get released. And we wanted to tie into that system so we could get push notifications when new gems are released. But that wasn't kind of like, we didn't want to put work on the rubygems.org team to get this up. So this came a lot later. So if we look at the API endpoint, it's really two parts. There's like the database that we're using, which we took from rubygems.org's Postgres data. So Nick gave us a Postgres dump of the rubygems versions and dependencies tables, but none of like the private user info, any of that stuff. From, I guess, like it was a few weeks old, and from that we could bootstrap the whole process. So inside the rubygems table, we just really are listing the names, and then in the versions you have a link to the rubygems, and then basically the number of platform and whether it's a pre-release gem or not. And then inside dependencies, it's where you actually link the dependency information. So if Sinatra depends on rack, you'd have Sinatra as the specific version, like Sinatra 1 through 2, and then depends on rack, that would be the rubygem ID, and the requirements would be whatever the Spermie operator or whatever you have there for the requirements listed. So that makes up sort of the whole relational tables that we have on Bundler API. And from there, we constructed this really awesome query to get all the information back. So one of the things you have to make note of is at the bottom here, you see the scope. And so when you have a dependency, you can have both runtime and development. And if you don't scope this, you get into crazy circular dependencies. So also when you're deploying an app, you actually probably don't care about developing for that gem at that time. So restricting this to runtime is really important. And then so here's literally like the call minus instrumentation code to just do this not graph here. So we have API v1 dependencies, and then make sure that we're returning like this octet stream back to bundler API, and we're literally calling the Marshall dump of like all the dependencies here. And so this get dumps method just pulls the gems off the parameter list, splits them, makes an array, and then sort of calls this dep calc method, which essentially runs the query and massages it. So just for posterity, here is like that method here. So we call the SQL query, which I showed before, and then we go through each of them and sort of just put them in that format that's similar to the slide I had before of what it looked like for the API here. So given all that, that kind of just makes up the whole web part of when you query this API endpoint, it returns the proper data back. And so now that we have that part working, we need to get sort of the sync code to make sure when people push new gems, you actually get those gems back. And so the initial thing we implemented was this polling mechanism that would literally just go through, hit the index, and try to populate the data in our like sort of cache in Postgres. And so it needs to really just do two things. So it needs to get the new gems into our local cache, and it needs to find, even though this is much rarer, like it still needs to find gems that were yanked, like if there's a bad release, and mark them to make sure not to return them back when people were doing bundle install. So they're not getting gems that have maybe security problems like Andre was talking about, or other bug releases that the gem authors don't want people to be downloading. And just to give you a sense of, so when we were building this at the time, I believe it was like, there's a gem released every 5 minutes was the stat that I got from the gems team. So it was kind of important to try to keep this as fast as possible. So inside of this, we just had this sort of just this worker pull up here, and we start it, and then we go through, we fetch all the specs from the monitor index similar to what Bundler does, and we just go through and set up worker jobs for each of whether we need to yank or add them. So we go through, and each of those jobs figures out, do I need to yank this gem? Does this gem actually exist inside of the local cache here? And then we have this poison thing, and then we wait for this pull to finish. And that's sort of, we just have a rate pass that sort of goes through and does this over and over. So if we look at this consumer pull that we built for this, it's like pretty simple. It uses Q from standard libs thread library. And what we do is you can specify sort of how big you want the pull is, so how many threads you want to spawn up to do work. And then, pretty standard, like I queue some jobs on there, so you just add it to the queue. When you start it, you actually create all the threads and make sure they're running. And then join just joins on all the threads and waits for it to finish. So it exits cleanly. And then we have this poison object. So what this does is it's this special object that's inside the run loop. When we queue a job, you just check if that job is a poison object, and if it is, we know to exit cleanly. So all those poison objects are at the end, and you have one for every single thread that you're running. So to make sure each thread has to get one. And so that's sort of the consumer pull there. And so one of the things when we tried to, so our initial run of this was it took like 16 minutes, I believe, to sort of go through the indexes every time. And that definitely is not like fast enough. People are going to run into problems when they push gems and have them not be updated. So one of the things we implemented was we had just like the 304 if modified since. So we would run this in a loop and just make sure, okay, have the indexes been updated? If not, then like let's sleep for a minute. And then the other thing we did was in memory we would keep track of all the stuff from the database in a hash, and if we would just check this hash, so we wouldn't have to essentially destroy our database for every single call for every single gem of every single gem spec there. And then we would just slowly update the hash. So once after the first run, it would be warmed up, and it would only take like a minute or two to actually run this thing, so we can keep it up to date pretty easily. But then that was just like pretty resource intensive to just sort of like add like one gem every 5 minutes. So we've now moved to this webhook system thanks to Andre and Evan Phoenix. And so right inside of rubygems, so this is in rubygems.org. This is some of the code. This is the code minus like some security or some like parsing stuff to like make sure things are clean. But essentially we just have this like JSON dump, and anytime you push a gem, it sends a request to Bundler API and lets us know that a new gem has been updated. And then we just have tokens there for security, so you can't just like push to this endpoint and like put faulty gems into our database. And then we also make sure to have a timeout here, so in case like Bundler API is down, or for some reason like it can't hit us, or it takes too long, like it doesn't prevent you from pushing your gem out, and then we'll just pick that up through the rate pass later on. And then, so this is the code on Bundler API side. It's literally just a post method that calls the same add job as in the rate pass, and we just run it and make sure that it gets added properly. So all this code is publicly available. If you go into the rubygems.org, you just go to Bundler API. All of our Bundler API code is there, and then obviously the rubygems.org code is under rubygems.org under the rubygems organization on GitHub. And so building it is one part, but the hard part, I think, for any of you guys who actually maintain stuff in production, which I assume is most of you guys, like it's actually the service and maintenance that takes up most of the time and work. So one of the things to give you a sense of like how this is running, so this runs on Heroku right now. We have 6 dynos running uniform. I think it runs 3 workers each, and then we have a Ronin database for reads, and then we have an ICA database, which is significantly bigger. I believe the Ronin has like 1.7 gigs in cache, and the ICA is like closer to 4 or something like that. And so basically all of our reads for the API endpoint go through the ICA database, and then any of the writes just go to the master. So we're sort of splitting the workload there. This made a lot of sense early on when we were doing the polling stuff, because every time you would do a write, it would essentially destroy the database by just like hitting it over and over again with all those queries and writing to it. So splitting it early on helped us a lot with performance there. And so other things we had to do to sort of have a service that people could rely on in the community was PagerDuty generously donates an account, so thanks to them. And Andre, Larry, and I are always on call for this, so anytime it goes down, we get a text or an email to let us know like there are errors happening or the service is down. We use Papertrail, which they've donated this to us as well, of just like being able to store the logs, so we can go back and look at any log data to analyze bugs or problems. And then we also use Librato heavily. Larry did a lot of work on this to sort of get us a dashboard of like, what does it look like? What is our performance? What is the expectation here? And it's been super helpful to sort of see whether we need to scale or upgrade our databases. Like during the security releases, our graphs would be really interesting because a new Rails gem would come out and everyone would like upgrade their gems and like our service would kind of go down, so we had to scale up. And so having these graphs were helpful a lot because we didn't always get notified when some of this stuff happened. So all the Librato metrics are publicly available at this URL. I think it's also on the gembundler.com site. If you go to the sponsors page, there's a link to this, so you don't have to memorize it or try to type it in if you want to look at it. But yeah, so all that stuff's available. And then we also have things like error counts and other things that hit PagerDuty to let us know like if there's a spike in errors, like make sure to let us know to see if like it's a problem in our app code or if Heroku went down or something, and to let us know that we're doing all this stuff. So sort of just to dive real quickly in like how we set this up with Librato. We're using the metrics gem. I highly recommend it if you're going to use this. And you just sort of sign up for Librato account, set all this stuff up, and then when you push production, it will ping Librato under your account. And then in development, we set the logger to go to dev.null. We initially did not do this. And then so we ran the server locally. Our logs would just get spammed with like reporting metrics. So that's not super helpful usually when you're trying to test stuff up locally. So make sure you do that. And then the nice stuff with metrics is it allows you to really easily like set up timer information if you're not going to order histogram graphs just by calling these things around methods and actions. So really easily allow us to construct instrumentation around certain parts of the application. And I really want to hammer this point in, but like this Bundler API is meant to be a community project. So I don't know if we've done a super great job of it, but we're trying to make this as transparent as possible. Like all the code is open source. All our graphs are publicly available. Like there's no secrets here. We're not trying to keep information away. And really we want to make it a project that people in the Ruby community are like proud to be part of, or if they want to help out in, it's like super easy to do so. Either reach out to Andre or I, and we'll more than happily like talk to you about it and get you set up like even today on like how to get this stuff up and running. And I think it actually provides a lot of benefit like with regards to things that we can do. Like this is sort of just the bare minimum of getting the API endpoint running. But now that it is up and running, like there's a lot more things we can do. So if you're wondering things you can help out with, so with regards to visibility, monitoring on call, like that's an ongoing thing. And anything you guys have, just like information or knowledge from doing your jobs of just like, how can we have better visibility? Like what are things that we can do to monitor our app better? How can we make our on-call rotation something? If you guys want to help out with on-call, that'd be super awesome too. And then also like coding-wise, like for the community, like one of the things that we've talked about a lot after building the service is we want to have the ability for Bundler to pass like a unique token for every time you bundle install, so that when on the server side we can sort of track a whole gem file install. So now we can get like, what is the average size of most gem files? Like how many dependencies do people have? Like how long does it actually take? All this like usage metrics to sort of build like get information to make Bundler better. B, like interesting information to just give to the community. Like our gems grow, like our gem files growing over time. Like is Rails adding like more dependencies as more releases are happening? Like stuff like that. And then the next part is sort of integrating with rubygems data. So what that means is, I think it was kind of a pain in the butt, like to sort of get all this information out of rubygems. Yes, it's like all publicly available. Like anyone can go to the index, fetch this information, parse it, do stuff with it. But it'd be much easier if you could just like query some API that has yet to be built of just like, I just want the incremental diff, or I just want like this specific information, and sort of making that much more easily accessible to the whole community versus being like, I need to download everything and then figure out like the 2 things I want from all this data every time I want to do something. So that's something we would like to explore more. And then other things that those are sort of the ideas that I had, or that we had on the team just talking about this stuff that we'd like to go forward to do. But I'm sure there's tons of stuff that as a community that you guys would like to see if you wanted to step up and build some stuff into this service. Definitely trying to make it a service for the whole community here. So I want to give special thanks to Andre for all the work on Bundler and then helping out maintain this Bundler API service with me. Larry was super instrumental in, I guess, doing literally all the instrumentation in the app initially and getting us set up with Vibrato for the first time, and then putting in metrics and sort of taking the sort of first dive and trying to make us like a real production service where we can monitor and actually see what is going on here. And he continues to help out all the time with this. And then Daniel Farina from Heroku was the initial person who helped me with spiking out the initial app when we first did this when we built it out. And that's kind of how all I had in the first section. I don't know how much time I have left. But does anyone have any questions, I guess? Awesome. Okay. So, bonus round. Sweet. So, one of the things that, as we've been doing the service that I've been working on is this Bundler API replay service. And so if we look at this graph here, so we have our production app, which is the thing that everyone hits. And what we can do, since it's all hosted on Heroku, is that we can take like log trains and then essentially just we had this idea of like trying to replay all this traffic to a bunch of staging apps. So the idea behind this is like we could stage we can have a staging app with staging code. We can be like, oh, what does this look like with Ruby 2? Like, because we're currently running on MRI 193. Like, what does this look like if we try to convert this after JRuby? Like, what is the performance? Like, are there a bunch of errors? Like, or any other configuration. Like, I want to switch to Puma. Like, what does that look like? Stuff like that. I thought it would be super helpful to actually get production traffic on it and see the load and see how it actually performs. So this is kind of the idea behind this whole project here. And so this lives under my GitHub accounts, Bundle API Replay, sort of where all the code is there. And so the key part to making this all work is, so on Heroku we have these log range things, and there's this beta feature called HTTP log range. So if you ever use Heroku at all, you have, you're probably familiar with seeing something like this. You get this routing log, it tells you like the method, path, host, and a bunch of other like routing statistics. And then you also get like all your other logs. So for Sinatra, there's like the standard Sinatra log there. And if you're using Postgres, it will show you your slow query logs as well. But for this particular service, all we care about are the routing logs. And so in order to sort of like do this at home, you just need to enable the HTTPS drains labs feature. And then you just need to add a drain to the application that you want to drain the logs from. So this would be Bundler API, would be the app name on Heroku, because that's our production app. And then you just pass in, usually you want to set like some type of basic authentication here, just because you don't want people to be able to post like bad logs to your app. And then you just point like literally any HTTP endpoint, like anywhere in the world. It can either be on Heroku, it doesn't have to be. It just made it easier for us to save this on Heroku, so we're just passing it to this logs endpoint here. And so literally you can just build this Sinatra app that takes the post, and the body is the routing, or is the logs that are being sort of posted to that endpoint there. So I built some libraries here inside of this that will essentially parse through that payload and try to figure out, is this a routing log? And if it is, like, let's like go through all the sites we want to forward to and put this on like a queue and sort of go through and replay the traffic to those sites. And so back in the day when we were doing this experiment, we were originally running the app on thin using 6 dynos, and I was testing, I wanted to sort of see like how JRuby performed. So I went to a lot of like JRuby talks last year, and one of the things they kept talking about was like how much better JRuby is and like how great the performance was, but like all the benchmarks they gave me were like micro, like they felt like these sandbox, like awesome environment benchmarks. It's like I have this awesome algorithm and like I'm gonna do red-black freeze with JRuby versus MRI. And I kind of want to see like what does it look like in an actual app that I'm using day to day, and sort of see how that fared. So just a single dyno running 6 threads using Trinidad here should be hopefully equivalent, but I wanted to see. So one of the things that we did to sort of make the experiment sort of even was there's this feature on Heroku's Postgres system that has really changed how I do a lot of things. Is like you can have these followers, and so what it is you can spin up another database. So we wanted to spin up another follower database that matched the follower database that production was using. And so what this does is essentially like a mirror of your database, but we want it in its independent box, so it wouldn't A, affect production, and B, it would be as close as possible, like configuration-wise. So we spun up another one of those, and then we're just looking at the databases we have on Bundler API. We have this crane, which is just for random testing things on. We have the brown, which is like the production read follower, and then the violet is the one that I just spun up in the last slide for testing purposes. And then the Ronin down here, which is a smaller one, is sort of the master write databases that all the followers are mirroring from. So from there, we get kind of this graph here. I don't know if you can read it that well, but the blue graph is sort of the JRuby percentile, like the 95th percentile case here. So you see it's like kind of spiky. And then the purple graph there is what it looks like in production. So it's sort of much smoother for us. And then the like green graph like all the way at the bottom on the left is the like request per minute, so it's like 653. That's how much JRuby is processing there. And then the orange, the orange one is the request per minute on production. So one of the things that we noticed is like pretty much always the whatever we were testing against, like even if it had more dynos or anything, would always be under. And so there's definitely like some limitations with this test, but we found out that we probably need to do some tuning with JRuby to get better performance. But overall, like on one dyno, you can definitely get a lot more concurrency, like a good amount of concurrency just using Trinidad with Tomcat. And we definitely need to do some more tests to actually even like move over. But it was good to see that like you probably just can't move over like that. Like there was things we had to look into to try to get that performance to sort of stabilize, whether that was like we needed more memory or like we need to tune like some of the JVM settings. It was nice to be able to see those settings before like just trying it and just using a Apache bench or something. So the limitations of this thing was like there's definitely a lag here between like when production gets it and when like the replay service. We definitely make the replay service faster, but it's always going to be behind what production has. So the only way to get around this would be to actually sit something on production that forward traffic to production and then return that and then to the other things to make that more even. And the next thing that we also noticed was since we don't have something in front, like you're never going to beat production in speed because you're only going to get the same number of requests as production having. So that's definitely a limitation to take into account while you sort of go through these metrics here. And the other thing that really allowed us to be able to do this is this app is completely stateless. So if no one ever pushed any new gem, when you send a query to rubygems, the output should always be the same response. And I know this isn't true for a lot of the applications you guys are building, like there's sessions, you're dealing with users. So this kind of project has limited like usability, but it's definitely an interesting idea. And it's helped us out a lot as we moved our app over to Unicorn to sort of see like how that played out. So in the future for this project, one of the things I would like to do is sort of separate out these libraries that I have built in into like its own gem of like these are Heroku routing logs or these are Heroku like logs. Like using this library, we can easily like process stuff and like you can easily build your own standalone like log drain to do like anything you wanted. Like I want metrics on, like I want to look at the routing metrics, like boom, like access that information super easily, or like any of the other things. So having that as its own standard library, I think would be really awesome and pulling that outside of this project. And the next thing is like offline processing. So the ability to like just like take a sample log file of anything, sort of just pass it in and have it actually replay to a specific application, I think would be super useful. So we could take like the logs from potentially Papertrail and be like, oh, like our app went down during this time, like let me try to replay that and see if I can reproduce that in one of our staging apps, and see like if there is various configurations that would help there, or like easily like make it take like an input stream, like be able to just like tail a log from like maybe some other app and pass it through and like make that do the replay, sort of like have that happen locally or on Heroku or something. And then next thing is just like having some way to sort of do like processing later. So like being able to store the traffic and then at some later time being able to like replay that traffic at any point would be really cool. So definitely stuff that's like in the pipeline that I haven't really worked on at all, but would love help if people are interested in working on this project. But yeah, that's kind of all I had for this particular thing. So are there any questions? Sweet. All right, thanks guys.